This lecture will introduce you to basic geospatial analysis techniques, such as spatial and aspatial selections, buffering and dissolving, overlay operations, table operations, and geocoding. Geospatial data analysis is the application of operations to manipulate or calculate coordinates and/or related attribute data. Geospatial data analysis is applied to solve problems such as determining bus routes, delineating flood zones, and determining suitable sites for construction. Spatial data analysis uses spatial operations to manipulate or calculate. This is in contrast to analysis that does not use spatial operations to manipulate or calculate. As a note, SDA will be used to refer to spatial data analysis for the remainder of this lecture. As an example of a spatial data analysis, this is an analysis flowchart for delineating watersheds using multiple input data layers to produce an output of watersheds. While this model may look complex, you'd be surprised at how each portion of the model is really not that difficult at all. The true power of spatial data analysis is the culmination of all these different analysis methods. For each spatial data analysis, you must consider the input, operations, and output. SDA typically involves using data from one or more layers to create an output. Therefore, relationships that can exist between the number of inputs to the number of outputs are 1-to-1, 1-to-many, many-to-1, and many-to-many. Speaking of the output, it is more important to note that the output may not always be spatial in nature. For instance, the output of an SDA may be a statistic or a report, which is not spatial in its nature. There are 7 basic geospatial analysis techniques that I will examine in this lecture. They are selection, buffering, dissolving, overlay operations, classification, and table operations, and finally geocoding.